this video, we're going to introduce you to key parts of a CNC milling program. We'll cover the program number, comment information, tool offset numbers, and work offsets. We'll also learn how to safely start running a program using single block mode, how and when to use rapid overrides, and the distance to go position display. We'll also talk about how to use our senses of sound, feel, and sight to identify if our program is cutting well. Now remember, watching these videos is a great first step to learning the basics of running a CNC machine, but nothing can replace hands-on experience. Be sure to contact your local HFO to talk to them about getting time in front of a CNC machine while it's actually working. All right, let's get started, and we'll take a look at the program that's currently loaded and ready to run. Typically, the first line of a CNC program is the program or O number. It's the identifying number that differentiates one program file from another. And as the name suggests, it begins with the letter O and can have up to 5 numerical digits after the O. We can see here that I have program O00087 loaded. The next thing you typically see in a CNC program are comments written in plain English. Now these comments provide information about the program. So when a line of text is surrounded by parentheses, like this, the machine knows not to treat these comments as part of the program. Most often, the first comment you will see will be the part number and drawing revision letter or number. Now for this program, I've got part number 20-9854 and revision C. Now it's very important to check that the part number and the revision level match the part you are supposed to be making. And by checking my drawing here, I can see that they match. If they don't match, ask your supervisor to double check. There are several other pieces of information here, such as the machine the program was made for, some info on what machine options and features are needed, and much more. Now these comments will vary from programmer to programmer, but soon you will come to recognize the way that the programmer in your shop does it. Often, the list of cutting tools used in the program will also appear at the comments at the beginning of the program. They show a description of the cutting tool and the tool number. And a well-organized CNC program will typically include the tool description comment every time a new tool is called. When you're running a new job for the first time, it's very important that you pay attention to the tool list and which tools the program calls. As the machine operator, you are the final check on the work done by the programmer and setup person. You have an opportunity to catch a potential mistake just by paying attention and verifying that the tools listed in the program match what the program is actually doing. The work offset should also appear in the comments at the beginning of a program. There may also be comments with instructions for what to do when the program reaches certain points or codes in the program. Here we see an example of this. When the program is running and reaches this line here that says M00, the machine will stop and wait until cycle start is pushed again. These codes are typically used when a program needs to stop and the operator must take some sort of action, like flipping the part over to reclamp, measuring a dimension, or just clearing chips out of a pocket before a finishing operation. Okay, so now we're acquainted with the kinds of comments you might see in a CNC program. Next, we'll talk about actually running a CNC program. CNC machines are fast, so once you hit the cycle start button, you really don't have time to react if there's a problem. Because this time is so short, machine operators need to be familiar with slowing down operation of the machine for the first part they're running out of a batch. This process consists of just a few simple steps, and we start our first part slowly so we have a chance to double check everything seems right before we start moving quickly. Once we know everything is working correctly, it's full speed ahead. So the first thing to know about is single block mode. Single block is activated by pressing the single block key on the keyboard, and we can see here that there is an icon on the screen to verify that I've entered this mode. In this mode, every time you press cycle start, the machine will execute just one line of code. Each line of code can also be referred to as a block. So in single block mode, we execute one block or line at a time. The program will not advance past the current block of code until cycle start is pressed again. Now this allows you to slowly step through a program the first time you run a part, so you have time to make sure everything looks right. We're showing you this so you have an understanding how to safely run a new part the first time. But in the beginning, this is normally a task for the setup person, so ask your supervisor if this is okay for you to do. Now that we are comfortable slowing down the machine, let's talk about G&M codes. In an earlier lesson on G&M codes, we talked about the G00 rapid motion commands and G01 linear motion commands. G00 quickly commands the cutting tool to move into position at the starting point of the cut, while a G01 feed commands actually performs the cutting. The G00 rapid command has its own set of override keys here on the keypad, labeled 100%, 50%, 25%, and 5%. When we say override, it means we are changing the default value of a command. The rapid override keys allow me to change the speed of rapid moves from 100% all the way down to 5% of maximum speed. So when I'm getting ready to run this program for the first time, after I enter single block mode, I'm going to press the 25% rapid override button to slow the speed of all G00 rapid motion commands to 25% of maximum speed. Now located right next to the rapid override buttons are override keys for feed rate and spindle speed. I want to be very clear, you should not change the feed rate overrides or the spindle overrides. The programmer determined that this program should cut at a particular speed and feed rate, and that depends on many factors. Changing these overrides may cause damage to the cutting tools, the workpiece, or even worse, the machine. Let your setup person worry about the spindle speed and the cutting feed rates. Do not mess with these. Just remember, the rapid overrides slow things down, which means it takes your machine longer to make a part. Now this is fine for now, since we're just making sure everything is running like it should be. But once you start running parts in production, don't forget to set this back to 100%. Your supervisor will not be pleased if the machine is running production at less than 100%. Okay, single block is on. I'm at 25% override. It's time to press cycle start. The first action a program usually takes is to call the first cutting tool. This will appear as T1 M06, assuming tool number 1 is the first tool in the program. This T code defines which tool to use, and the M06 is the command to perform a tool change. If that tool is already in the spindle, no tool change will take place. Now in this case, tool 1 is not in the spindle, so you will see a tool change. Now is a great time to compare the tool described in the comments to the actual tool in the spindle. Here in my program comments, I see that tool number 1 is a 2-inch face mill, so I'm good. But if I start the program running and I see a drill loaded in the spindle, now I know something's not right. It's time to call my supervisor. After you verify that the correct tool is in the spindle, continue pressing cycle start until you get to the first motion commands. Now remember, we're only advancing one line at a time because we're in single block mode. Typical CNC mill programs position the X and Y axes first. The comments at the top told me that X0 and Y0 is located at the back left corner of my block. My program starts with the vise located in front of the door, so it's easier to load my part. Then the first rapid positioning command that's on this line here will move the table so my cutter is right beside the workpiece and ready to cut. This block of code is also where you should find the work offset code. It should be G54, G55, or similar. It's wise to review this work offset command and compare it to the work offset command listed in the comments. If there is a discrepancy between the two, let your supervisor know. The next likely move in the program is to call the tool length offset, turn on the spindle, and approach the workpiece in the Z-axis. The code will usually look like something that I have in my program here. Before we press cycle start again, let's take a quick look at the program so you understand what's going to happen. G00 we know is the rapid position command. G43 is applying a tool length offset. H1 is the actual tool length offset being used. The Z-axis position is Z0.1, and that tells us where the machine is to move based on the current active offsets. And finally, many programs will turn on the coolant with M08 at this point. There's a lot happening on these lines, but basically we're telling the machine to move quickly, turn on the spindle, use a tool offset. The tool offset is H1, move the Z-axis down to just above the part, and turn on the coolant. Now at this point, I want to do one more thing before I press the cycle start button again. I want to press the position key and scroll over to distance to go. To me, the most valuable position display while in single block mode is distance to go. This display does exactly what its name implies. It tells you how much farther each axis has to travel before we reach the end of the current block. Now let's take a look at the distance to go display. I can see by looking in my machine that my cutter has no more distance before it reaches the commanded position. And I can confirm that in the distance to go display. But let's say that my distance to go here says 3 inches. I can see the tool is right at the part, which means I know the tool will crash into the part if it moves 3 more inches, which means I'm going no further until I talk to my supervisor. Since I'm still in single block mode, my cutter finished moving down to the part and is right beside the workpiece waiting for the next command. But I can't see anything because the coolant came on due to this M08 command. Luckily, we have a way to override that command. I just press the coolant key here and it turns the coolant off. Now I can see my tool, and sure enough, it looks like it's the correct distance above the part based on this distance to go. But one important word of caution here. If you manually turn off the coolant at any point, you must be sure and remember to turn it back on again before you start a line of code where cutting occurs. Most cutting tools rely on coolant, so if the programmer wants coolant on, there's a good reason. If you forget to turn it back on, best case you make a bad part. Worst case, you destroy a tool. Now that I feel comfortable that I have the correct tool in the spindle and my tool is in the correct position, I'm going to press the coolant key again and start the coolant. Now I'll press the cycle start button and begin cutting the part. Okay, the program is running now, but I'm not going to walk away, especially if this is the first part run on this program. The first thing I want to watch for is to make sure the coolant is aimed in the cutting zone. The coolant nozzles and the P-Cool nozzle position should have all been properly aimed by the person who set up the job. But if any of the tools aren't getting coolant directed on them, let your supervisor know immediately. But looking isn't all we're doing here. We also need to listen. Different materials make different sounds when they are cutting, and in general, they all make a nice uniform low tone. A cutting operation that is squealing and making a chattering noise is not cutting properly. So let's listen to a couple of examples. This is what a good cut should sound like. And this is a bad cut. You don't have to know exactly what the problem is in order to hear the difference. So if you hear something that doesn't sound right, it probably isn't right. Alert your supervisor and ask them if it is supposed to sound like that. You can also feel the machine enclosure while the machine is cutting well. Often, a change in vibration will accompany a change in sound. So understanding how the machine enclosure feels while your machine is cutting well will help you determine if a program is not cutting properly. Another telltale sign of a problem is a change in the appearance of the cut surfaces, referred to as surface finish. If you notice a change in surface finish, notify your supervisor immediately. One more way to tell if a program is no longer cutting well is a change in the spindle load or the axis loads. The spindle load meter is located here, and the axis load meters are located here. Again, pay attention to the spindle and the axis load values when the program is cutting well, and monitor the load meters to see if the loads are increasing. It is normal for the load to increase gradually over time as you cut more parts and the tools get duller. but you should be alert for large differences in loads that happen quickly. This is a sign that you may be about to have a tool fail. And again, it's time to notify your supervisor. Okay, let's do a quick recap of the things we've learned in this lesson. We learned about the unique O numbers that identify different programs. We learned about comments surrounded by parentheses and how they should list the tool descriptions and offsets used in the program. We learned about how to safely start running a program using the single block mode, rapid overrides, and the distance to go position display. We also learned how to identify tools and tool numbers, work offsets, and M00 program stop commands within a program. And finally, we learned to monitor how well our program is cutting by listening to the sound and feeling for vibration, monitoring spindle and axis load meters, and visually looking at surface finishes. Thanks for watching, and we'll see you in the next lesson.